Hi, everybody. So I thought it might be helpful if I just record a video going over a couple of the Pascal triangle problems where you're going to use Pascal's triangle to expand a binomial being risen to a power. So we started this one in class, but we'll go through it again. So I want to expand 4t minus 2 to the fourth power. Now remember, you could expand this, make a bunch of boxes and multiply it out, but that would take quite a long time. And so we have Pascal's triangle that we can use as a little bit of a shortcut. And so the first thing I'm going to do is I'm just going to, on the side, go ahead and write out the first few rows of Pascal's triangle. So remember, at the top, you always start with a 1. Right? And then the next row is just a 1 and a 1. Okay? And then remember, 1s go all down the side. So on each end, there's going to be a 1. And then I'm going to add the two numbers here. 1 plus 1 is 2. Right? So 2 is going to go here, and then there's a 1 on the end. That's my third row. My fourth row, I'm going to have a 1. Then to get this number, I'm going to add these two. So 1 plus 2 is 3. Here, 2 plus 1 is 3, and a 1 on the outside. I'll do a couple more rows. I have a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and 1. I'll do one more row. 1 on the outside. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and then a 1 on the outside. Okay. And you could keep going, but for the two problems that we're going to do, we don't really need to go any further. So remember, we're going to look at the exponent here to figure out which row in Pascal's triangle we're going to use. And so there's a couple ways you could remember this. Remember, I said you can either use these numbers here, or just remember that that very top row, that first one, is actually 0. Think of that as 0. Then we have 1, 2, 3, 4, 5, and so on. So the row that we want to use to help us expand this is the 1, 2, 3, 4, fifth row down. It's the row that has the 4 here that matches my exponent. So this row here is the one I'm going to use. Okay, now this has 1, 2, 3, 4, 5 numbers in the row. So I'm going to start by writing out 5 blanks. So there's 1, 2, 3, 4, 5. Sorry. Okay. And what I do right away is these are the coefficients of each term here. So I'm going to write those out in order. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. And then another good habit to get into is after you fill in the numbers, we're going to go ahead and put two sets of parentheses on each line, because this is where we'll put our numbers and our variables from here. Okay. All right, and so in class we talked about a pattern that we noticed with the exponents. Okay, so remember, I'm gonna look at the first set of parentheses. Okay, this is going to be where our A term goes, our first term, and we noticed that when we expand this, the exponents on A decrease. Okay, so it starts with an exponent of 4, and with each term it decreases by 1. Okay, so that the exponent on this term will be 4, then it will decrease to 3, then it will decrease to 2, then it will decrease to 1, and then it would decrease all the way to 0. Okay. And then B is going to go in the second set of parentheses, and we noticed that the exponent on B increases by 1 each time. So this starts at 0, and the exponent here increases by 1 each time. So 0, 1, 2, 3. Sorry, I'm running into my Pascal's triangle here. 4 there. Okay, and then finally what I'm going to do is I'm going to put A, remember, in the first set of parentheses and my B term in the second set of parentheses, and I'm going to do this all throughout. Okay, so A is 4t and B is -2. That negative goes with B. So I'm just going to go ahead and put those in. Okay. So this is kind of the setup. You kind of want to get in that habit of writing out your triangle, listing out each blank, putting your coefficients, putting your parentheses and putting your exponents, and then plugging in your A and your B in for those parentheses. And so now we're going to actually simplify this. So I'm going to raise these things to the exponents. Okay, so I'm going to do this term first. I'm going to leave this 1 out here for now. And I want to do 4t to the 4th power. So to do that, I'm going to raise both 4 and t to the 4th power. Okay, so you could raise 4 to the 4th power on your calculator. Right, 4 to the 4th power is 256. And t to the 4th power is just t to the 4th power. Okay, now I'm going to do -2 to the 0 power. That's just 1, right? Anything to the 0 power is 1. And I'll go back and I'll simplify this later. Okay, so this kind of came, remember, from that first blank. I rose those to their powers. Okay. I'm going to do the same thing here. I'm going to leave this 4. This is 4 times. 4 to the 3rd power is 64. T to the 3rd power is t to the 3rd power. And -2 to the 1st power is -2. I'm going to leave the 6. 4 squared is 16. And t squared is t squared. -2 to the 2nd power is +4. Leave the 4. 4 to the 1st power is 4. And t to the 1st power is t. -2 to the 3rd power is -8. I'm going to leave the 1. 4 to the 0 power is just 1, and t to the 0 power is just 1. Anything to the 0 power is 1, remember? And -2 to the 4th power is 16. Okay. And so for the last step here is I'm just going to multiply this through and simplify everything. So I've got a 1 times 256 times a 1. So that leaves me with 256t to the 4th power. Okay. All right, now from this blank, I've got 4 times 64 times -2. When I multiply those out, I'm left with -512, and then t to the 3rd power. I'm going to multiply these numbers. So 6 times 16 times 4 gets me +384, and then I have a t squared. Multiply this out here too. 4 times 4 times -8 is -128, and I'm left with a t. And then 1 times 1 times 16 is 16. Okay, let me just double check, make sure I got that. All right. We're going to go ahead and do number 11. So again, I'm going to go ahead and make Pascal's triangle over here. You could use the one I made up above, but I kind of wrote on that one, so. Okay. This time my exponent is 5. Right? So if I'm looking at these numbers here, I can see that I'm going to be using this row here. It's actually the 6th row down, right? I want to use this row this time. Okay, and I'm going to need 1, 2, 3, 4, 5, 6 blanks. Okay, so I'm going to write that out. Okay. And again, I'm going to start with these numbers as my coefficients. So 1, 5, 10, 10, 5, and 1. I like to go ahead and put my parentheses in there because I'm going to be putting my A and my B terms inside those parentheses. Okay. I'm going to do that pattern with my exponents. So for my first set of parentheses, it's going to start at an exponent of 5 and decrease by 1 until I get to 0. So 5, 4, 3, 2, 1, 0. And then my second set of parentheses, remember this one starts at 0 and increases by 1 until I get to 5. 0, 1, 2, 3, 4, 5. Okay. Remember my A term is my first variable or number there, and B is the second. And I'm going to just fill in my parentheses with G and 6. So I have everything filled in now. And so my next step is to go ahead and actually raise these things to their powers. So I'm going to leave, 1 stays there. G to the 5th power is just G to the 5th power. And 6 to the 0 is 1. Leave the 5. G to the 4th power is G to the 4th power. And 6 to the 1st power is 6. G to the 3rd power is G cubed. And 6 to the 2nd power is 36. I have G squared. 6 to the 3rd power is 216. G to the 1st power. And then 6 to the 4th power is 1,296. G to the 1st power, or to the 0 power is 1. And 6 to the 5th power is 7,776. I'm just going to multiply everything and simplify. So 1 times a 1, that's just 1. This term simplifies to G to the 5th power. Okay, 5 times 6 is 30. So this simplifies to 30 times G to the 4th power. 10 times 36 is 360. 10 times 216 is 2,160. 5 times 1,296 is 6,480. And then 1 times 7,776 is 7,776. This is my final answer. And we're done.